And this is the distance along the curve. From one endpoint to the next. Okay, so when you're dealing with an arc length, now it's no longer talking about just the measure of the arcs. Now it's actually talking about that one-dimensional length. Okay, so it'll be measured in inches, centimeters, whatever units that you're describing. And it's still going to be tied to arc measures, but if I wanted to find the arc length here, so again I'll just refer to these points as A, B, and C. Okay, arc length is designated with a lowercase s. Okay, and so when you're finding your arc length, it's a portion of the circumference. So let's talk about circumference again. The circumference of a circle is given by what formula? Josh?
2 pi r.
So one of them is 2 pi r, and we could also use 2r is equivalent to d. So these are your two equations for circumference. So when you're dealing with the arc length, which is this lowercase s, it's some portion of a circle's circumference. Well, let's figure out what portion that is. If we know the arc measure, m, of AC, we can find its arc length by taking m over, and what would be a complete circle back onto itself? What rotation or measure? An arc measure of 360. Okay, so if you want the fraction of a circle's circumference that's represented by an arc length, you'll take m over 360 times that circle's circumference. So here is your equation for arc length. Now, you're going to have one of two forms for this. It either depends on whether you're given the radius or the diameter. So arc length is either going to be m over 360 times 2 pi r, or it's going to be m over 360 times d pi. It doesn't really matter which one you use, because the calculations are pretty basic that distinguish these from each other. And so if you're told what the radius is and you want to use this formula, you can. You can just double the radius. If you're told what the diameter is and you want to use this equation, you just cut it in half and plug that in for r. Okay. So here's the type of question that you might see like in a real basic sense. We'll do some more advanced examples tomorrow. But let's say I gave you, in circle P, all right, so this is lowercase s, not capital S. Capital S is segment. But if you want to find the arc length of QR in this problem, and what you're told is that this angle has a measure of 30 degrees, and PQ, the radius of this circle, is 8. Can you find what the arc length QR is equal to? Okay, so what is our m value? If our angle T is 30, that means the QR has an arc measure of
60.
double that, 60. So we get 60 over 360 times, and because we're given the radius, let's use 2 pi r. The radius is 8. And we can now calculate through. The factors of 10 cancel. 6 goes into 36 6 times. 2 goes into 6 3. And when you multiply across, you get 8 pi over 3. And so just to, since this comes up here, if I wanted the exact or the approximate answer, the pi button on your calculators is located right here above this caret symbol. So if you wanted to type in 8 second function caret to get pi divided by 3, and since I'm in auto mode, if I want it in decimal form, I can either hit the green diamond button and highlight this diamond, or I can put a decimal in my display, hit enter, and I get my answer, 8.3775, etc., and round it to whatever it might ask you to round it to.